Why can't scientists definitively figure out the creation of life in the universe? It's about the internal geochemical mechanisms of a planet being able to forge life from inorganic chemical elements.
We know that Earth has had life for about 4 billion years, and in that time, 99% of the species that have ever existed have gone extinct. But every single species alive today all trace our lives back to one tiny little cell at the bottom of the ocean. Its name was Luca, or the last universal common ancestor. Now, Luca probably wasn't the first thing alive on this planet, that would be Fuca, but it is the one who survived, and a tiny piece of its DNA can be found in every single living thing on this planet. The weirdest part about this whole entire thing is that we still don't really know how life came to be in the first place, and how a bunch of non-living things came together to be living things. There's a million different theories, but one of my favorites is that these life cells hitched a ride here on the asteroids that brought us water. But in reality, it's still one of the greatest mysteries of our planet, and probably the universe.
But if comets were the thing that brought water and life to planets, why did they bring it to only one planet in the entire solar system? Why not Venus? Why not to Mars? The living organisms and water we now see on the planet Earth were created by the Earth through a very tedious process over billions of years and not through random falling rocks. Why can't scientists definitively figure out the creation of life in the universe? The fact is this: everything you know, everything you've been taught, is wrong. Elon Musk, Neil deGrasse and NASA do not have any clue about how the universe really works. It's all just regurgitated nonsense that they themselves were spoon-fed. The very first form of biological life on Earth was actually created and forged inside the planet's deepest interior. It's about the internal geochemical mechanisms and the core of a planet being able to forge life from inorganic chemical elements and their isotopes. The core of the Earth is not just a magma mixer that keeps turning and churning for no reason. Instead, the core of the planet actually conducts nuclear knockout reactions, increasing the quantity of the isotopes of iron and gaseous elements present within the planet's deepest interior. The Earth's core is what produced all the water that's now on the Earth's surface, which is why the isotopic signature of Earth's water matches no other source of water in the solar system. Before the adoption of the notion of fossilized trees being the main source of petroleum, the abiotic hypothesis pointed to the principle of the full suite of hydrocarbons found in petroleum being generated in the Earth's mantle via abiogenic processes, where it was these source hydrocarbons from those abiogenic processes that eventually leached or migrated out of the mantle into the crust, and they remained trapped there until major earthquakes, or until we released them in our drilling expeditions to acquire more crude oil from these underground deposits for our insatiable energy needs. Even though this thing called petroleum crude oil is still actively being created by the planet, abiogenic petroleum crude oil that will continue to be dug from the Earth in perpetuity. The proposal suggests that with the core of a planet, or its internal central regions being responsible for its overall energy and chemical resource output, in this scenario it would not only generate radioactive isotopes of heavy elements, but it would also produce charged ions and many stable isotopes of the lighter elements that would get carried away by magma and convection currents. Which is part of the reasons why volcanoes produce so much violent lightnings and why volcanic eruptions tend to produce an almost endless amount of ash and gas, as clouds, instead of only lava flows. As such, a planet could sustain life by trapping specific elements within energy-supplied pockets, deep within the planet's crust, allowing stable chemical bonds. These pockets, within Earth's crust, serve as interconnected reaction chambers sustained by chemical ions, thermal energy, and catalytic minerals. This dynamic environment accelerates the synthesis of diverse organic compounds, marking the inception of self-contained ecosystems of carbon-based chemicals. The successful pockets would resemble hydrothermal vents that support striving ecosystems, whereas the failed ones would resemble veins of petroleum crude oil. Most people erroneously conflate the process that create petroleum with the process that create coal. Coal is indeed crushed fossils that exist at depths up to a mile deep. However, the petroleum crude oil that can be found some 4 miles down was definitely not created by the same process. As the successful reaction chambers evolve to create a wide diversity of polymers and not just basic forms of hydrocarbons, the eventual emergence of protein molecules signifies the inevitable arrival of enzymes. These proteins and enzymes, acting as natural reactants and catalysts, unlock pathways for complex polymer chains, storing chemical information and energy. The narrative unfolds a tale where life's emergence hinges on the interplay of diverse elements, energy dynamics, and catalytic processes within the planet's depths, and not in dormant puddles of water or crash-toasted comets on the surface of the planet. The significance lies not only in chemical ingredients but also in energy availability, reaction activation levels, and catalytic integrity. The chemical pathways the process from the core of the planet has unlocked are what give rise to the information and chemical pathways that we now see unfolding across the immutability of biological patterns that have sustained for some 4 billion years on this planet. DNA is not a simple computer program, like most people seem to think it is. Instead, it is actually the entirety of an elaborate operating system, stored at the molecular level. Written not in binary ones and zeros, but written in ACGT phosphate double helix molecular arrangements, with billions of lines of code, and this is true across all living biological entities that reside on this planet. This, therefore, makes cell organelles and enzymes more like basic programmable or automated machine units, as powerful as personal laptop computers, which means that the whole process of DNA, RNA, enzymes, and protein synthesis is less like random reactions, and more like a very coordinated conveyor value chain system running on binary code, much like the macro-scale systems that run on silicon copper integrated microchips. Consequently, using this scale in context, your brain is not like a supercomputer, instead it is each cell in your body that is like a supercomputer. As such, a person's brain is more like an entire network of billions of microscopic supercomputers, all connected to each other simultaneously. And the so-called AIs that are now popular are nowhere near that level of connectivity or complexity, and cannot be compared to the level of processing power required to be considered as fully cognizant of their surroundings, or expected to make real non-programmed decisions with instinctive ingenuity, to be truly sentient, or to have an understanding of divinity, destiny, or divine purpose. This pattern orchestrates a cosmic symphony of very organized energetic systems from the Big Bang's inception to the formation of galaxies and the intricate designs of flowers, to leaves on trees, and the orientation of all other living things. This intricate dance of numbers, axioms, and mathematics underscores the profound connection between the universe's grandeur and the delicate beauty of nature and life, uniting the macrocosm and microcosm in an unbreakable bond. As the universe expands and evolves, galaxies transform, stars and planets born and die. Over millions of years, life evolved and diversified, beyond the understanding and complexity of humanity. We look up at the night sky and marvel at the wonders of creation. We deploy telescopes and spacecrafts to explore and study the cosmos, and we use theories and models to explain its origins and evolution. We write books about creation and the universe, exploring exoplanets, galaxy formation, and the search for life through the eyes of Hubble, Newton, and Darwin. Despite all our advancements, we still do not fully understand the singularity that started it all. As we gaze up at the stars, we know that the story of the universe is still unfolding, and we are hoping one day to unravel its mysteries. Join us on an epic journey through time and space with Creation and the Universe, a thrilling book series that explores the mysteries of the universe, from the Big Bang to the formation of galaxies and stars. Discover the ancient history of the world, including the legendary civilizations of Egypt and Atlantis, and explore the origins of life on Earth. Don't miss out on our limited time offer. Get your free copy today on Amazon.